October 2017. On an otherwise ordinary night, the Pan-STARRS telescope in Hawaii spotted something strange. At first, it looked like nothing more than a faint speck against the stars, but its motion didn't add up. It wasn't circling the sun like planets and asteroids do. It was moving too fast on a path that meant only one thing. It had come from far beyond our solar system. This was the first confirmed interstellar visitor in human history. Astronomers named it ʻOumuamua, a Hawaiian word meaning a messenger from afar arriving first. And with that, the messenger revealed itself, and the real mysteries began. So what exactly did this messenger look like? Well, that's where things got weird. ʻOumuamua wasn't shaped like the space rocks we usually know. Asteroids and comets are generally roundish, lumpy, potato-shaped. But ʻOumuamua, it was long, thin, oddly elongated. Some scientists described it like a cosmic cigar. Others argued it could be more like a flat pancake, depending on how it rotated. Either way, it didn't fit the mold. Even its surface was strange. It reflected sunlight in a reddish hue, hinting at an ancient weathered body, scarred by millions of years drifting through interstellar space. And it didn't just float peacefully. ʻOumuamua tumbled, spinning unpredictably as it sailed through our solar system. No steady rotation like a planet, no simple spin like a coin. Instead, it was chaotically rolling like a log caught in a river current. This was not just a rock. It was a visitor, carrying with it the scars and secrets of another star system. Perhaps one that formed billions of years ago, light years away. For scientists, it was like finding a message in a bottle washed ashore, a message from across the galaxy. And naturally, the question became, what was this thing really made of? A comet? An asteroid? Or something entirely new? Here's where things get even stranger. ʻOumuamua wasn't just unusual in shape. Its entire journey broke the rules. Most comets and asteroids are loyal to the sun. They're born in our solar system and tied down by its gravity. They orbit in ellipses, returning again and again, sometimes brushing close to Earth, sometimes disappearing into the outer darkness before swinging back. But not ʻOumuamua. This object came in fast on a path astronomers call hyperbolic, which basically means it wasn't bound to the sun at all. It swooped in, used the sun's gravity to slingshot around, and then kept right on going, back out into the interstellar void. It wasn't visiting the sun like a planet making a loop. It was passing through, never to return, and it was fast. At its peak, ʻOumuamua was cruising at nearly 196,000 miles per hour. That's fast enough to travel from Earth to the Moon in just 2 hours. No spacecraft we've built could ever catch it. This speed was the smoking gun. ʻOumuamua hadn't come from our solar system. It came from somewhere else. Another star, maybe dozens of light years away. And the odds of us catching it in this one brief window were astronomically small. In other words, the fact that we even spotted it at all was almost a miracle. This was the point where the scientific debate went from curious to downright wild. If ʻOumuamua wasn't behaving like a normal comet or asteroid, then what was it? Most astronomers stuck to the safe bets. A bizarre shard of rock, a fragment of some distant planet, or an icy body with physics we hadn't yet figured out. But then came the bold idea. What if ʻOumuamua wasn't natural at all? Harvard astrophysicist Avi Loeb stepped forward with a suggestion that grabbed headlines worldwide. Maybe, he argued, ʻOumuamua was some kind of alien technology. Now, he wasn't saying little green men were steering it. His point was subtler. ʻOumuamua's acceleration could be explained if it was something like a solar sail, a thin, flat sheet designed to catch the pressure of starlight and ride it, the way a sailboat rides the wind. And if you imagine a sail drifting between stars, suddenly that eerie, flat pancake description didn't sound so crazy. Of course, the whole idea of alien tech passing through our solar system was bound to stir excitement and skepticism. Many scientists pushed back, arguing there were still natural explanations on the table. But what couldn't be denied was this. For the first time in a long time, the question of extraterrestrial life wasn't just the stuff of sci-fi, it was part of a serious scientific conversation. ʻOumuamua had cracked the door open, and even though most researchers lean toward natural causes, the possibility, even a slim one, that this was a messenger from another intelligence was too tantalizing to ignore. And just as suddenly as it arrived, it was gone. ʻOumuamua didn't linger. By the time astronomers realized how strange it was already racing away, back into the deep dark between the stars. We only had a few short weeks to study it. A cosmic blink of an eye. Telescopes all over the world scrambled to catch glimpses, to measure its brightness, its color, its motion. But even the biggest observatories could only do so much. Within a month, the messenger was too faint to see. By the time debates over its nature were heating up, it had already vanished into the distance, far beyond the reach of our instruments. No spacecraft could chase it down. It was simply moving too fast. If we'd known just a little sooner, maybe, just maybe, we could have launched a mission, a probe to follow it, to take pictures, to touch it, to finally know. But instead, we were left with only a handful of blurry data points, just enough to spark questions, and far too little to answer them. ʻOumuamua slipped into the darkness, leaving Earth with nothing but mystery, a once-in-a-lifetime encounter that ended almost as soon as it began. ʻOumuamua may have come and gone in the blink of an eye, but its impact on us was lasting. Before 2017, the idea of interstellar objects wandering into our solar system was mostly theory. Astronomers suspected they must exist, but nobody had ever seen one. Then, suddenly, there it was. Proof. ʻOumuamua cracked open a new chapter in astronomy. It reminded us that our solar system isn't an island. It's part of a cosmic highway where debris, fragments, and maybe even artifacts from other stars drift silently through the galaxy. And it did something else too. It gave us a sense of urgency. If another messenger appears, we want to be ready. New projects are already underway. Powerful telescopes like the Vera Rubin Observatory in Chile, designed to scan the sky night after night, catching the faintest moving objects. Even space agencies are considering missions that could intercept the next interstellar visitor to study it up close before it vanishes into the void. ʻOumuamua also gave us something less tangible, but maybe just as important: wonder. For a few weeks, humanity shared the same thought. What if? What if it wasn't just a rock? What if it was built, not born? What if we really did catch a glimpse of something far older and stranger than ourselves? Whether natural or artificial, ʻOumuamua was a reminder that the universe still holds mysteries far beyond our imagination. And one day, another traveller will come. When it does, maybe we'll be ready to say more than just hello. Until then, we look up at the stars, waiting for the next messenger. Thanks so much for watching our today's video. If you liked it, please subscribe to our channel, like and share the video with your friends. Your support means the world to us. And finally, what do you guys think? Is ʻOumuamua really an alien technology? Comment below and let's discuss.